In this video, we will talk about functions and transformations. We are going to talk about functions and transformations. Functions and transformations. Okay, for the functions and transformation, we really need to know parent functions. We have to know the parent functions before we do anything else. Okay, my parent functions are, I'm going to give you parent functions. Please write it down, copy it down, and memorize them if you don't know them. Y equal x, that's one of my parent function. It's going to go straight right here through origin. I have another parent function, y equal x squared, and this one is going like a parabola, like this, U-shaped. Then I have y equal x cube, and it goes like this. You have y equals square root x, which goes something like that. And then I have y equal ax. A is a real value, like a could be 2, 3, 4, 5, 6, any number. So the parent function for this is going to be, like, for example, this is 1, and it's supposed to go through this 1 and go all the way here. Then I have y equal ex, and e is like a pi. Its e value is 2.7 something something, but it's 2.7. So the graph should be similar to the one ax, because a is also a real value, but I'm just gonna do it both. This is 1 actually. There. Then we have ln x, y equal ln x. Ln is a natural log. We will talk about this, but you need to know the parent function for this, and it goes through the x equal 1, like this. Then we have another parent function, which is y equals sine x. Sine x goes through the origin, like it's going to go through here, like this. That's the difference between sine and cosine. Sine x goes through the origin. Then we have y equal cosine x. Cosine x actually goes, this is 1, it's going to go through like this. So check the difference about the things. Okay, now what transformation we will talk about? One transformation, the first one is vertical and horizontal translation. We will talk about vertical and horizontal compression. We will talk about vertical and horizontal stretching. And every one of them has a rule. If you memorize the rule, write it down somewhere on the paper, then you will be good. Okay, the first one that we will talk about is vertical and horizontal translation. So let's talk about translation. For example, I have a function y equal f of x, some kind of function, and I have a plus k. This k is a constant. This is a constant, like a real value. So this plus means that my graph is going up and down, like a y-axis up and down. So this one is going up. So this is my vertical translation. If I have y equal f of x minus k, then again this means the graph is going down, and it is again vertical translation. Like it's going up and down, that's vertical translation. Okay, I'm going to give you example for this. For example, I have y equal x squared. I'm just going to make it simple. And this is a real function. Then I have another one. We did the translation and it went -1. We did the translation x squared plus 1. Translation means when you just move a little bit here and there, up and down here and there, like you just grab it and move it, grab it and move it. That's translation, okay? So x squared, for example, this is x squared, and I'm going to draw the x squared function first. The x squared is a parabola like this, right? Then the translation means this one I'm going to use a different color for this actually. So for this one, I'm using the yellow color. And since this is minus, which means it's a translation vertical, but it means I'm going down. So this is down. So how many times I'm going down? Once. So this is 1 right there. And my graph went down exactly the same thing, but it went down 1. So that's a translation vertical. For this one, I'll use a different color again. This one is talking about the graph is translating up because I have a positive. So my graph is going up 1. This is 1. I'm talking about from the main graph. Main graph is the one in purple, this one. So this one is a main graph. It went down, so it goes, the orange one goes like that. The green one is going up, then this graph is going up once. And translation up and down means we are going to do the y-axis, like going up and down. Okay, so let's talk about stretching. Okay, next one is, second one we talk about, in the horizontal translation means the graph going this and that way, this and that way. Like for example, the graph goes here, and this is a translation how many times. If it goes here, then this is a translation horizontal, I don't know how many times. So that's a horizontal translation. And we will work on that. We will work on that on some questions. Okay, let's try stretching. The next one is stretching. In stretching, the rule is y equal k f of x. This k is greater than 1, then that's a vertical stretch. Vertical stretch. If I have horizontal stretch means if I have y equal f kx, like this. Like this k is with the x, not as a coefficient of the function in the beginning. It's something like that. Any number, any value with the x is going to be your horizontal. But if the k is less than 1 or greater than 0, then that's a horizontal stretch. Horizontal stretch. The example for both of them. Example is, for example, I have y equal x squared 2x squared, right? The original function is y equal x squared, but I changed it to 2x squared. Do you see this is a k in the beginning of the function x squared, which means I'm talking about vertical stretch, and it's greater than 1. So it means this is my vertical stretch. If I do, for example, another example for the horizontal, if I have y equal f of kx, which was your horizontal stretch, and the function is, I'm taking a function y equals absolute x, and then I change that to y equal 2x absolute, then do you see this 2 is with the x, which means I'm talking about this k. So if it's less than 1 or make it half, because it says less than, so make it half. If it's less than 1 or greater than 0, then it means it's a horizontal stretch. Okay, let's talk about compression. The third one is compression. I have, for example, the rule is y equal f of x if I have y equal kf of x, if the k is less than 1 or greater than 0, in this case in the coefficient like in the beginning, then it means that's vertical compression. For example, I have y equal x squared, the original one, and I'm changing it to y equal half x squared. Then this half is the k, which is less than 1 or greater than 0, then it's a vertical compression. Let's talk about horizontal compression. It's going to be y equal f of kx, the same thing. If k is greater than 1, right, like I have, for example, y equal absolute x, and I'm going to change that to y equal 2x absolute, then it means, let me write down, then it means I have 2 is greater than 1, then that's a horizontal compression. So these are the few rules that if you remember, you're good to go. Now we have reflection. Let's talk about reflection. Reflection rule is, for example, if I have something like this, like a negative in the beginning of the function, then this means I'm reflecting reflection across x-axis. I'm going to give you an example for this. For example, I have y equal x cube. This is an example. Y equal x cube minus 4x squared plus x plus 1. And I'm plugging in for y negative f of x, which means this whole function is going to be negative. Like I'm multiplying negative with the whole function. X cube minus 4x squared plus x plus 1. This is going to change. Negative x cubed, I'm distributing this negative. Negative times negative is positive 4x squared. Negative times positive is negative x. Negative times positive is negative 1. So this function, when you have a negative in the beginning of the function, that's a reflection across x-axis. Okay, let's talk about reflection across y-axis. For the y-axis is if we have y equal f of negative x. So what we're going to do, reflection across x, that one was x-axis, yeah, so this is y-axis. Okay, I have a function x cubed plus 4x squared plus 2x. For example, this is my function, and the question is asking, is there a reflection across a y-axis? I don't know. I have to plug in this negative x for every x in the function. So I'm going to plug it in, negative x cubed plus 4 negative x squared plus 2 negative x. For every x, I plugged in negative x. So this is going to turn negative x cubed anyway. This is going to turn plus 4x squared. This is going to turn negative 2x equal y. Now, yeah, we do have a, it means there is a reflection across y-axis. I changed it, right? If it doesn't change anything, like you don't get anything, then there should be neither. Then we have odd and even, or symmetric about origin or something. Odd and even functions. Odd functions means when the function is symmetrical about origin, like it's going through 0, 0. For example, and I'm going to give you a rule for this. If I have negative x and you get, when you plug in negative x for the function and you get negative f of x, like the whole function has a negative in the beginning, then it means this is odd. The function is odd because it's symmetric about origin. Symmetric about origin mostly for the graphs. When you see the graph going through the origin and it's reflecting, that's odd. But if you have a function like a regular function, I'm going to give you an example for this. For example, I have f of x equal 1 over x. Then I don't know if this is odd or even. I have to plug in negative x for x. You see the whole function I got is negative 1 over x, and my function got negative like that, which means this is odd function. How are we going to tell even function? Even functions. For even, it's symmetrical about y-axis. That's for the graph purposes. This one, when we have a function. If you plug in negative x and you get back the positive function, then it's even. Like you get the original back, so that's even. Now, let's talk about few other examples that you guys will see on this objective. For example, the question is asking, I have a question, for example, I have f of x equal x to the power of 5 minus 2x squared plus 3x, and I have f of negative x plus 2. The question is asking, is this a reflection across y-axis reflection? That's what they're asking. Is this a y-axis reflection? I don't know. The easiest way to do it, I'm going to graph this on Desmos, this part, and I'm going to plug in negative x plus 2 up here, and I'm going to graph that too. And we'll see if it's reflection across y-axis or if it's reflection across x-axis. We don't know that. So one of my function is this. My another one is going to be this negative x plus 2. Okay, so I'm going to plug in negative x plus 2 for every x. Minus 2 negative x plus 2 squared plus 3 negative x plus 2, done. So I'm just going to leave it like this. I'm going to solve this because, you know, 5, it's a huge thing. I don't have that much time. You guys don't have that much time either because quizzes are very timed. So I'm just going to graph both of them on Desmos, and then we will see if it would work on the if it's a reflection across y-axis. So I'm going to type in here graphing calculator. I'm going to go there and I will type in my functions. So the function one is x to the power of 5